Today, we will explore the fascinating world of electrolyzers, how they work, what they cost, and their role in shaping India's green hydrogen future. Now, coming to our main slide, which is about the technical comparison of the two most available electrolyzer in India right now at this moment of time is alkaline and PEM electrolyzers. So let's dive into a detailed comparison between alkaline and PEM electrolyzer, two key technologies driving green hydrogen production. Alkaline electrolyzer use a liquid electrolyte like potassium hydroxide, while PEM system rely on a solid polymer membrane such as Nafion, and these fundamental difference shape their performance, costs, scalability. So PEM electrolyzer require several imported components like platinum, iridium, titanium, plates, and advanced membranes, making them more expensive but highly efficient. In contrast, alkaline system use nickel and stainless steel, which are more accessible and cost effective. Capital and operational costs are significantly lower for alkaline system. They also offer longer lifespan up to 90,000 hours compared to PEM, which are only 40,000 hours. However, the PEM delivers ultra pure hydrogen at 99.99% purity and respond rapidly to power fluctuation, making it ideal for integration with intermittent solar energy. When it comes to scale, alkaline technology is mature and suited for large industrial projects. PEM is still emerging but rapidly scaling, especially for mobility and fuel cell application. In terms of cost contribution, the stack dominates both system about 50 to 60% in alkaline and up to 70% in PEM. Balance of plant and power supply also plays key role. Major cost driver for PEM include the membranes, precious metal catalyst, and titanium components. For alkaline, it's the electrolyte, electrodes, and diaphragm replacement. Finally, global supply chain matter. PEM components are sourced from US, Japan, Europe, and South Africa, while alkaline systems rely more on China, Germany, and domestic inputs. Uh, Choosing between AEL and PEM depends on your priority, cost, efficiency, scale, or integration with renewable. Both technologies are vital to India's green hydrogen roadmap. Now coming to our next slide, which is about a cost contribution breakdown. So let's compare two leading electrolyzer technologies, alkaline and PEM, across key performances and cost metrics. Starting with the electrolyte type, alkaline electrolyzer use a liquid solution like potassium or sodium hydroxide, as we all know, while PEM system rely on solid polymer membranes offering compact design and higher efficiency. Speaking of efficiency, alkaline systems typically operate at 65 to 70%, whereas PEM electrolyzer reach up to 80%, making them more suitable for energy intensive application. When it comes to hydrogen purity, PEM leads again, producing hydrogen over 99.99% purity, ideal for fuel cell and mobility. Alkaline system deliver around 99.5, which is sufficient for most industrial uses. Operating temperature is another differentiator. Alkaline electrolyzer run below 100 degrees centigrade, while PEM system operate between 50 to 90 degrees centigrade, allowing faster startup and better dynamic response. Capital cost is a major consideration. Alkaline systems are more affordable due to simpler material and manufacturing. PEM system though more efficient are costlier because of imported membranes and precious metal catalysts. Finally, in terms of dynamic response, PEM electrolyzer excel. They respond quickly to power fluctuations, making them ideal for integration with solar and wind energy. Alkaline systems are slower and typically require battery support for grid stability. In summary, PEM offers higher performances and purity but at premium cost, while alkaline provides a robust cost effective solution for large scale industrial hydrogen production. Now let's dive into the cost structure of alkaline and PEM electrolyzer, two dominant technologies in green hydrogen production. Starting with the component cost breakup, and electrolyzer stack is the most expensive part for both type. It accounts for 55% of total cost in alkaline system and even more 65% in PEM system due to the use of advanced membranes and catalysts. The balance of plant, which include pumps, piping and control system, makes up 25% for alkaline and 20% for PEM, reflecting the more compact design of PEM units. For compression and power supply, alkaline system allocate 10% to compression, while PEM system dedicate 15% to power electronics, supporting their faster dynamics response. Alkaline also include 10% under other costs, which may cover auxiliary system and installation overhead. This category isn't specified for PEM. Now let's compare capex per megawatt in India versus global average. In India, PEM electrolyzer cost around 21 crore per megawatt or 2.6 million, while alkaline system are slightly cheaper, around 19 crore and 2.3 million. Globally, the costs are lower. PEM system average is 17 crore, while alkaline range from 13 to 15 crore. Uh, this shows that while PEM offers superior performance, it comes at a higher cost. Especially in India, alkaline system remains a cost-effective choice for large-scale hydrogen deployment. Now coming to our next slide about the comparison of the electrolyzer components, critical components that influence cost, performance and supply chain risk. Starting with PEM electrolyzer, they rely heavily on advanced material like membranes made of naphthalene, a high performance polymer that enables efficient proton exchange. Precious metal catalysts like platinum and iridium, which are essential for high activity and durability, but also drive up cost due to their scarcity. Titanium plates used for their corrosion resistance and conductivity, especially in acidic environment. On the other hand, alkaline electrolyzers use more abundant and cost-effective material. Nickel, which serves as a primary catalyst for hydrogen evolution. Stainless steel used for structural component and electrodes. Diaphragm is separate hydrogen and oxygen gases while allowing ionic flow. These material choices not only affect the capital cost and efficiency of the system, but also have a implication for scalability and local manufacturing. For example, India's access to nickel and stainless makes AEL more attractive for domestic production, while PEM system may face supply chain constraints due to reliance on imported precious metal. Undertaking and understanding this materials dependency is the key to building a resilient and cost-effective hydrogen economy. Now, coming to this slide, which break down the cost in both Indian rupees and USD, the PEM system are more expensive due to imported membranes and catalyst. Alkaline system benefit from the simpler, locally sourced material. This is all about the different companies that we are in field of electrolyzer manufacturing, and this is also a very important slide which shows that how the how the global leader including ThyssenKrupp, ITM Power, Nel, ASA and Plug Power, all these companies are driving innovation and scaling up production across Europe, the US and China. Electrolyzer manufacturing depends on mineral like platinum, iridium, nickel and titanium. India must secure supply chain and explore domestic alternative to scale sustainability. Now coming to the mineral production, as far mineral production is concerned, it is concentrated in a few regions like South Africa and for platinum, China for rare earth and Europe for titanium. Titanium strategies, partnership and recycling will be a key hence to for a long-term sustainability. Hydrogen production, as far the hydrogen production and the cost is concerned, we have already shared the previous preceding slide. And as for these, producing 1 ton of hydrogen daily requirement 75 megawatt of electrolyzer capacity, that is 65,000 megawatt hour of electricity and 9,000 liter of pure water will be required. Solar integration depends on 100 megawatt capacity and 120 to 150 acre of land. So coming to these all details is here in this particular slide, as we can see, and as we can also go through the cost breakup uh, that what we have just discussed. And this is what the different countries are now segregating their specialization in manufacturing green steel electrolyzers.